Good day, grade 9 science students. Today what we're learning about is series and parallel circuits. Our learning goals are going to be the following. We are learning how to design, draw circuit diagrams of both series and parallel circuits. We're also going to eventually do some labs where we investigate the relationships between current, down here, potential difference or voltage, and resistance in these circuits. So we've got parallel and series circuits. We're going to learn what they are, and we're going to combine those ideas a little bit with current, voltage, and resistance. Okay, here we go. Okay, a series circuit, all it is one path. So an electric circuit in which the components are arranged one after another. And the example is on the right here. If you take a look, we have one path for my electrons. We leave the negative end, we go through three lights, we go through the three lights, and we go back to the positive side of the battery. That's one path, and all the electrical components are arranged in one after another. So if I cut this off, if I split this off with a pair of scissors, that's a picture of some scissors, if I cut it, bam, right there, or I cut it along here, or anywhere along this, the lights will go out because I've interrupted that pathway for those electrons. They can't flow, the electricity goes off. Parallel circuits, on the other hand, have more than one path, and that means that the electrons can go into a bunch of different directions. And the points that divide the circuit are called junction points, the points where you can take different paths. So for example, this right here would be considered a junction point because the electrons, or actually, sorry, this side would be the junction point. The electrons move up, and as they move up, they have a choice to make. They can go directly forward, they can go down this direction, or they can go back up in this direction. Now, the interesting thing about parallel circuits is if we wire stuff this way, if I stop this path right here, if I break this path right here, the electrons still have two other options to take. I can even snip this path here, and the electrons will still be able to flow down the middle path. It's only if I snip the three paths that the lights and the electricity would stop flowing. So this is actually how your house is wired. If I cut one wire in your house, all the lights won't go off. Only one or a few lights will go off. But the point is that we are going to learn that we wire our home in parallel for this reason. An interruption or break in one pathway does not affect the other pathways in the circuit. Okay, now we're going to talk a little bit about resistance in parallel circuits. Resistance is a material's opposition to flow of electrons. So if we have a parallel circuit here, if we add more resistors, something interesting happens. We actually don't impact the resistance on other pathways. So if I add a pathway up top here, and we add a resistor in there, it slows the electrons down. Remember, the electrons are going to go in this direction. They go up, and then they have a choice of which way to go. And these guys are wired in parallel. And because they have a choice of which way to go, the top pathway is not going to affect how the middle pathway's resistance is. It just doesn't impact it because there's multiple pathways for that to take. In fact, as we add more and more resistors in parallel, something interesting happens to the overall resistance that the electrons face. It actually decreases, which is crazy when you think about it. But a practical way to actually wrap your head around it is if you had a hose, and originally it has a lot of pressure in that hose, but if you put an end on it and split that hose in two directions, so now that hose is feeding two separate hoses, as the more connections you actually add to it, the resistance in that hose actually decreases. The more ends you add to that hose, the less pressure would be in that hose itself. Hopefully you understood that, but we got to understand that as electrons move through a circuit, they get some resistance. And especially when they move through resistors, but when they're wired in parallel, if you give it more pathways, the resistance actually decreases overall. And individual pathways actually have their own resistance. We'll talk about that more in some equations coming up soon. Interestingly enough, as well, when we talk about amps or amperes, amps are measured, the unit for amps are amps, okay, and the letter we use is I, okay, so some number 6 amps. So you can see that we have 6 amps leaving our battery. This is a 2-cell battery, you can see it there, and as it goes through it has 3 pathways, and we can see that 1 amp is choosing to go down the bottom pathway, 2 amps are going in the middle pathway, and 3 amps are going in the top pathway. Well, how the heck would 3 amps go up top and 1 amp go below? Well, all that could happen there is, if you think about it practically, the 3 amps that we have right here, this has the least amount of resistance. And it has the least amount of resistance. I know that because the most flow is going through there. So the one with the least amount of amps has the the greatest resistance. This has the greatest resistance here because only 1 amp is choosing to go down in this direction, which means there's quite a bit of resistance preventing a lot of amps going through there. Remember, amps is the amount of electrons, and the least amount of electrons are going through the bottom. Also remember that the amps add up in a parallel circuit. 3 plus 2 is 5 plus 1 is 6. So therefore, when we come out this end, 6 amps will also be going back to the other side of the battery. It's just dividing up down the pathways. So here we're going to talk about voltage, and voltage is actually interesting. Here we have two batteries that are back end to end, and because they're end to end, I'm going to say that this is actually a form of series because they're connected together. So if each battery is 4.5 volts, that means you would have 9 volts of power. If I measured the difference in potential energy between the one end where the electrons are leaving and where they're coming back. Now what's interesting is they will carry that 9 volts of voltage or electrical power, and when they hit each one of these guys, the voltage that we would measure across each one of these resistors would be 9 volts. Okay? And the interesting thing is that when the electrons get back to the other end of the battery, which is right here, when everything is all said and done, they have to have used up all their energy. So when they go in, they start with 9 volts, and when they leave on this path, it's already right back to the back of the battery, and so is this path, and so is this path. So we say that it has lost all its energy, so that means that the amount of energy that is across each one of these resistors is 9 volts. So in summary, what we can say for parallel circuits is that each load uses all the potential difference supplied by the battery. So this means that the voltage across different things, different loads, if they're wired in parallel, is going to be the same. So voltage remains the same across a parallel setup. The interesting thing about this as well is if we have amps, the amps are divided up in the different pathways. So amps is the amount of electrons, and the amps can go in different directions. So if I have more than one direction, the amps will add up together, like so. So this is our parallel example. You can see that we have multiple pathways, 6 amps leaving the battery, but there's 3 paths it can take, 1, 2, and 3. And what this is saying is path 1 plus path 2 plus path 3 should equal the amps total, which is 6. So it does indeed equal 6. 1 plus 2 plus 3 is 6. Resistance might be the hardest thing for us to understand. It's a bit of a different weird equation, but the resistance that in parallel that an object experiences is actually equal to the inverse of each individual resistance that something feels. So the inverse is 1 over. So the resistance of the first thing, resistor, the resistance of the second, resistance of the third, will be measured in a funny symbol. It's called ohms, which measures resistance. If we add those all together, but we add the inverses together, we will get the inverse of the total resistance. And what we find is that the resistance actually decreases as we add more resistors.